So let's get going. Anyone want to talk about any submissions or things they were able to get done this week?
I did do a submission. Nothing great in terms of results, but I have some sort of direction now.
Cool. So you want to share what you saw and which direction you're headed in?
Yeah. Do you want me to share now?
Yeah, go ahead.
Okay. Can you see my screen?
Yes.
Okay. So first thing
Oops, it went. Yeah, now I can see it.
I ran my LSTM for 30 epochs, and it gave a curve that's similar to what you guys have been seeing. The training loss. You can see the graph, right?
Yes.
Yeah. So the training loss and a huge gap between train and validation, basically. I was able to see that as well.
Yeah.
And okay. So some things that I did wrong the last time. So one thing I did wrong was I had a couple of linear layers with no ReLU in between. So that was obviously a mistake, uh, since it's just equivalent to one linear then. So
Right.
I
Right.
kept a ReLU between them. I think all of you are familiar with what I'm trying to do here, right? It's just two LSTMs. Okay, I can just show that quickly.
Yeah. Followed by the linear, right?
Okay. Just give me a sec. Uh, yes. Two LSTMs, and then I concatenate the output from the two LSTMs, and then I have this sequential uh,
Prediction.
part. Yeah, linear ReLU dropout and then final output layer. So yeah,
Sorry, how much is, I forgot. I think you answered it last time. Yeah, that's the picture.
yeah, this is
How
basically,
wide are your, I think 512 you said, right? Embedding the output that comes out of.
embedding. Yeah, Python. Yeah.
So when you concatenate, you have 1K
Yes.
and you take it to 256 and then 1.
No. Just 512 again and then one.
Oh, okay.
Yeah. Yeah, and so yeah, so dropout helped me uh, to improve my validation scores a bit. So I was getting 0.6 as the log loss. Now it's 0.5. I mean, it's still not great in terms of actual numbers, but it helped a lot. My graph looks something like this now, and I can even
That's,
probably go. This is just 10 epochs. Maybe I could go even further than this.
yeah, now
uh,
the loss seems to be better than I have seen in any SBERT USC type of. But I don't know the axis, but is it the point 0.5? But between training and validation, they almost seem to kind of
yeah.
match, right? So
Yes. Then
the other thing, Gautam, I was going to suggest, and Raquel has pointed this out to me before, is to go a little bit more gradually from 512 to 1.
hmm, yeah,
So
that's
have more layers along the way with both ReLU and dropout.
yeah. Yeah, yeah, especially dropout helped a lot in reducing the gap between the train and validation, and batch norm made it very worse, like really worse. So when I just had dropout after the linear with, I mean, just batch norm instead of dropout, uh, my training loss became really bad. and yeah, things were just worse in comparison. So dropout of,
That's an interesting observation because I think that it may be worth trying because I think uh, I just tried two variations of the USC and SBERT, and one of the variations was what Steve had, which, if I recall correctly, did not have batch norm, but it only had one layer, much like you do, right? It's just exactly this, but I don't think he had a dropout either. Similar to this, I mean, meaning the numbers may be slightly different, but no batch norm. So that's an interesting observation that without batch norm it gave you better results is something else to play with.
yeah. I don't know if batch norm requires much more epochs, but the losses were just higher, and it was not even decreasing that well, I think. Maybe yeah, maybe there's only specific cases where batch norm works well. It just didn't work well in this
Yeah, I
case.
wondered whether in these embeddings, whether doing batch norm, I mean, it's an empirical thing. I don't, or maybe if anybody has seen any papers or any documentation, whether in NLP with embeddings being fed in, whether batch norm helps or hurts. But um, I guess transformers do use batch norms.
Yes.
Anyone? I don't recall off the top of my head. Anyone remember or can confirm?
Yeah, I think they
Transformers
do
use
use.
layer norms usually, not batch norm, but
Yeah,
layer
yeah,
norm.
layer norm. Yeah,
Sorry, what norm do they use?
layer norm. Yeah.
Layer
Layer
norm.
norm. Oh, okay. Okay. I see.
Okay. So I had some confusions. Like I referred a lot of other implementations by people. So is there any requirement of setting the hidden states to zero when it actually sets it to zero by default? Do we? I mean, I commented all of them out, and it seems to work really well. I mean, perfectly fine. So there is really no need of setting the hidden states to zero, right? If when does it, I mean, when it does it by default. Anyone
Yeah, I
know?
believe I recall Jeremy talking or mentioning, but I'd have to look at the code to see. But if it, as to you're saying that PyTorch by default initializes zero, so there's no need to do it.
Yeah. Yes. Yeah. Uh, Let me see if there's anything else interesting to show. Yeah, I was able to get the results in tensor board. Maybe I can show it now, I'm not sure. So there is this thing called summary writer, and you can just write your results. It will just write the losses to a file inside this directory location, and then you can open a tensor board in a different collab and can view all your losses accuracy graphs there. That was kind of convenient. um,
So even so you were able to do that even while using Torch, PyTorch
yes, yes, it just writes the loss values to a file
file.
which
Yeah,
is
and
later
visualization is helpful. Yeah, right. Yeah,
yep.
so that's good.
Yeah, I don't think there's anything else too interesting, but the thing here is like even the bias is very high, like the bias loss, I mean, because on a it's just a binary classification, and I'm still just getting 74%, which is very poor on a train set. So the bias is quite high. So the way to solve this would be to have bigger uh, network, right? So the next easy steps that I can do is make it a by Lstm, which I have not done. uh, okay, yeah, this is something else that I can do: swap question 1 and question 2, uh, which should help with the augmentation and stuff. And I'm trying 100 dimension glove now. I can replace it with the
300.
bigger gloves or maybe fast text or something.
Yeah, I think 300 glove ought to give you better results too, even with what you have, and you can check that way too, right?
Yep. Yeah, there's a lot of things that I can do to improve this. Then, so there's another type of architecture that I saw, which was called Manhattan LSTM. I can show it quickly here.
Mm.
Okay. Actually, they did it on the same Quora question thing, but it's using Keras, so I didn't. Okay, this is not the thing. Yep. So it's the same thing, embedding LSTM, and what they do here is they take the apps. I think this is what Money had showed in.
Yeah, there's a whole process, and there's the Siamese networks we haven't yet touched, but yeah, there is a
Yes.
method to handle this in with Siamese networks. Yep.
You just take the absolute difference and exponent. I mean, e raised to that. So I had a question here, like how. So when you take the absolute difference of something, uh, it's no longer differentiable, right? So how does the gradient flow back? Since it's not a differentiable curve anymore. Anyone knows anything about that?
What do you mean? You mean this particular equation, or in general, in when you take absolute? Because there is the I've seen well, I have to be careful with the mean absolute error, but now I don't recall whether it's used anytime as
So
a loss or just as a metric.
absolute always makes your curves kind of bendy at one point. It makes it take a 90-degree turn or something like that. So it stops being differentiable. So even in ReLU, what they do is they just
Yeah,
assume
at
that the
zero.
gradient is zero at zero.
Yeah.
They just have that assumption. So
So
I
this
don't know how
also
they.
is only not differentiable at zero, right?
Yeah,
Should be
probably.
differentiable everywhere else, right? Basically, if it's absolute, you'll end up with a V, correct? If you're plotting this
Yes,
one,
yes, yes,
so
yes.
only zero, and like you said, same
So they
like
would just
ReLU, I
okay.
would assume, yeah, that the same way it would be treated there. My guess, that's what I think is
Yeah,
happening. I'm not sure.
yeah, maybe. Yep, that could be it. Yeah, and the thing with the Siamese nets is the LSTM on the left and right shares weights. So that's another thing that I can try and just make it a Siamese network. So I just need to have a single LSTM which shares weights. Instead of having like RNN 1 and 2, I can just have the same one.
Mhm.
Uh, yes.
And
And
then, I was just thinking, and again, thinking loud, but I haven't thought through it deeply to see whether you can again use the hidden states and use, because you're just putting the hidden states through your um,
yeah, the
linear
final
neural
network.
net, right? So once you get the hidden state, you may be able to also do the abs difference and the element wise product and create a concatenation of those and use that.
Hmm.
See whether that gives
Concatenation
you
of
better
the
or
difference and the
yeah, with
product. Okay.
right with the hidden value. Because essentially when you do by LSTM, that's what you're doing, right? You're taking the forward and the backward and
Hmm.
concatenating them, right?
Yep.
So just like I tried doing the absolute of the difference and then the element wise product, you can do that with the hidden states and see whether that improves your score and then concatenate the result and then take it through your network.
Hmm. Yep.
So I actually
Uh,
finally read the sentence bird paper, and they tried both difference and product. And in their case, I think in the previous case, which actually used, I think I'm not sure if that one used by Lstm product help, but in their case, product actually hurt. So it doesn't always help.
Yeah, that it doesn't always help, but that's why I said you can try it. Actually, in my case, when I used just simple SBERT and USE, it helped in both cases.
Yeah, I think that's all I had. And then this is the common embedding layer. I can just have a same common embedding layer for both question 1, question 2. I don't think that will help too much, but yeah.
It will reduce your parameters. I guess your model will be faster, right?
But I'm not really training the embedding layer, right? It won't affect it in any way. One thing it could help in is if there is a
That's just
particular
the
word in question 2 which is not part of the vocab in question 1, and if a new question 1 comes with that particular word, then it could help. That's the only case I can think of where this helps.
Aren't both your embedding layers the same, though? Or are you using two different embedding
No,
layers?
my vocab is built separately.
Oh, I see.
So,
Okay.
yeah.
Okay.
So I use torch text and built vocab using that.
Oh, for Q1 separately and for Q2
Yeah.
separate. Okay.
Yep. I don't see any reason to do this unless you are having unless you're training the embeddings separately.
Right. Or combine Q1s and Q2 and then have a common embedding layer or something like that. I'm sorry. I have a common.
Yep.
Cool.
I think I had something else. Yep. Yeah. That's all I had. Okay.
Cool. Yeah. Anyone else?
I have a general question. In a sense, I'm on a Steve's notebook which he shared last week. How are you guys dealing with the training time? I tried to use it yesterday. It took me 6 hours on a GPU for one epoch, and then on a second epoch, after a couple of hours, it errored.
Yeah, it would have run out of memory or something, right? Did you run it on Colab or your local machine?
Colab.
Really? When I ran on Colab, it would take maybe about an hour per epoch, not 6 hours. It would take me about 4 hours to run the whole thing.
Yeah, that's what I saw your notebook. So I don't know why it took me 6 hours. So today
Are you using standard Colab? I use like Colab Pro, which tends to give you slightly better GPUs. I think it gives you what are they called, the P100s or whatever they are. Whereas when I used to use standard Colab, it was like hit and miss. It seemed to be half the time they'd give you like a really bad GPU.
Yeah. So I checked it. I think I got the Tesla T4. So let me check actually. So yeah, it's a Tesla T4 which I got today. So what I did was Steve, you are swapping those questions and you created the training set as twice.
Yep.
So I removed that and then started again, and that brought me down to per epoch hour and a half. So four epoch took me another 6 hours to do the training. So I was just thinking if I'm doing anything wrong.
I'm not sure, sorry, but yeah, it sounds like a long time compared to when I ran it.
So you are on Colab Pro though, Dinesh?
No, I'm not. I'm on a journal Colab. I think it's Colab Pro. Is it a Colab Pro is paid version or others?
Yes.
Yeah. It's like $10 a month, I think it is. But when I used to use standard Colab, quite often it would either give me like a rubbish GPU, or sometimes it wouldn't even give me one. It would be sort of run out. And so yeah, if you pay the $10 a month, you're sort of more guaranteed of getting a good one.
Okay, I probably do that because
the other thing, Dinesh, I would say is with the paid one, it doesn't log you out if there's not activity, which I ran into quite a bit when I was using the unpaid one. So that was another major problem as well.
Okay. So I probably do that because that the 6 hours and then 6 hours per epoch, and after 1.5 epoch, after 8 hours, it kicked me out. So that was, I'm better off going for a pro then. Yeah. Yeah. And just one observation, Steve, I'm still on an inference phase, but then I was comparing the validation accuracy, which I got versus you on twice the training set. The accuracy, I think there is not much difference. I was getting around 9 on a actual training set. I got not 0.9128, and then I see your notebook, it's 0.9138. So not huge difference as far as twice the training set is concerned.
Yeah, no, like when I doubled the size of the training set, it was it didn't really help me that much. It was a bit disappointing.
Yeah.
Yeah, so it didn't really give me any better results by doing that. I was expecting a lot more from it.
That's correct. Yeah, yeah. It's very small difference between the two. Yeah.
Yeah.
Did you try reversing test set and averaging predictions?
I haven't gone through one process yet, so I haven't tried that anything else other than just going through normal process.
Yeah, I haven't tried that either. I've just tried it on the training side. I haven't tried it at inference time yet.
And how much memory do you get with the Pro?
I'm not sure. Sorry, I don't know. I know there's an option you can click on to ask for extra memory, but I don't know how much it gives you.
Right. Okay. Well, I'll check it because again, on an inference time, it starts warning me about the memory usage.
Yeah, I don't recall either off the top of my head, Dinesh, but like Steve said, when you, I think there's an option to set up the notebook width or to change it even as you're running it or before you run it to increase memory flavor, but I don't know off the top of my head how much increases that provides.
Okay.
I did find when I was running the notebook, quite often I would run out of GPU memory. So like in the notebook there, you can see like there's like quite a few bits where I have like trying to delete stuff and do the garbage collection.
Yeah.
Even with that, like quite often I would need to sort of restart the notebook and like just load in the train network and run the inference by itself rather than running the whole thing in one go. So in some ways it might be better to split it into two notebooks, one for training and one for inference, to try and help with the GPU memory stuff. But yeah, like it is very much on the limit of how much memory it has.
That's correct. Yeah.
Yeah, I also had the same problem. I tried to switch just using SBIRD still. I tried to use the much bigger model instead of the 768, whatever, the Roberta Large, which is kind of the best model they have for this task. And of course, still using SBIRD, but that had each embedding is 1024 versus the 768. And that thing, even the training was substantially longer. And then, I ran, so I think Steve had a default of 60 epochs and it ran out of memory at around 55. But I was like, okay, you're done pretty much, and went on to inference. And even in inference, it took me with Distilbert took me an hour, whereas this thing took 4 hours. So just for inference. And obviously inference, it doesn't use as much memory, and as Steve pointed out in his notebook, he periodically garbage collects and flushes or deletes stuff that's no longer needed, which became mandatory to do if you wanted the notebook to continue running with the larger model.
Yeah.
Anyone else, Steve?
Unfortunately, I haven't sort of had much time to do anything this week on it, so I was going to look into Hugging Face with the link that Recolid sent last week, but I didn't get around to that yet. So John's talk today was pretty useful to sort of show what a Hugging Face could do. So
Yeah,
hopefully next week I'll pursue that.
yeah, that'll be interesting to see. It seems like prepped models that could be put to use with BERT. As I mentioned, anybody else want to share their submissions or scores or plans? So I kind of looked into two things. One, as I mentioned, I tried the Roberta Large. So let me share my screen, see whether can you folks see my screen now?
Yep.
Okay, so my earlier attempts were with DistilBERT, and as you see, SBERT has, or sentence transformer, which is using SBERT, that has a Roberta Large, and then it's this particular model, and that's a much bigger model than, it's about 1.31 gig. So as I said, my inference took much longer. My training couldn't finish to 60. It just ran out of memory at around 55 epochs. But even those things were okay. The saddest part of the story, though, is the bigger model didn't help. So now the thing I did do is to batch norms. So per the earlier discussion, that's something that I might want to remove the batch norms. Just do the ReLU activation followed by dropout and see whether that helps improve things. But net result of, and you can see that my thing died at, maybe you can't. Usually this thing would run to completion to 60 epochs, but you can see that buffer data was truncated. That's what happens if you run out of memory. Then running the model, you can still see the training validation loss difference. And in fact, you can see validation going up ever so slightly from, so maybe I should have stopped around here in 10 epochs, because that gives the lowest validation stuff. And then as Steve mentioned, he garbage collects and then deletes a lot of stuff. I ran this twice, which is why you see 0. Otherwise, you should see a bigger number. Inference ran it, and it ran for, you can see, 3 hours and 22 minutes. So very long time for running that. But the saddest part of the story was I got worse result than when I used the simple model and the LWEC models, which are more the DistilBERT models. So you can see that the score is actually worse, 0.37 versus 0.34. So it
Is
didn't
there
seem
an
to.
LR scheduler in place somewhere, or are you using a constant LR?
Good question. I think, no, I don't have a LR scheduler. I'm glad you brought it up, because I think that was something I was thinking of doing, but I didn't end up doing. So that might be something to try, along with dropping batch norm and trying it both ways. I already have one with batch norm, so maybe try one without batch norm.
Yeah,
In
I
the
think
regular,
like Arto point out, like putting in layer norm there could also help. That could be
oh
one
yeah,
more
that might be
experiment to
another
check,
idea.
right?
So layer norm and instead of batch norm, right?
Mm-hmm.
Yeah. So drop it or replace it with layer norm, and then use LR scheduler. I think those three are good suggestions to try. In the other SBERT things that I have run before, I've done it with this, with kind of a very basic model that Steve had, which is just like 2 layers or so, and didn't have any norm. But I think the layer norm is a good idea. So layer norm and LR scheduler are good things to try with this. And then I think if it doesn't give any better, I would say probably that we are reaching, barring augmentation. And on augmentation, the second thing I did, I'm going to stop sharing. Any questions on just this run? Oh, one other thing I might just want to show for people. Let me see whether it's, yeah, here. This is the SBERT, kind of the pre-trained models. And there's a whole bunch of them, depending on what you're trying to do. Much like we discussed BERT and then, classification, blah, blah, blah. But in this case, SBERT, sentence BERT, has paraphrase identification. Obviously, the first one I tried was this guy, DistilBERT based NLI STSB Cora ranking, which is trained on the neural language inference and the STSB data. And then fine-tuned on the Cora duplicate question stuff. So I thought that would give me the best results, and it still gives me better results than the best model here, which is for semantic textual similarity, which one would think would still be related, because at the end of the day, we are trying to determine whether 2 sentences are duplicates or not, which if you get a very high score on semantic textual similarity, you would think that it ought to do relatively well. And it does comparatively, but not better than fine tuning on the specific data set itself. And obviously the one I wanted to try was the very best one, because that would mean maybe that the other ones wouldn't necessarily give me better scores. So I tried this Roberta large NLI STSB mean tokens, which gives the best result for the semantic textual similarity task. So that's just FYI. So there's a bunch of models you can try and play with of SBERT for various, depending on the task. So these models are all for textual similarity. These 2 models are for duplicate questions. Then there's a bunch of models for information retrieval, blah, blah, blah. The one other thing I wanted to point out, yeah, as Yuri said, and I'd like his comments or thought, but I didn't read line by line, but I kind of quickly glanced at the SBERT augmentation paper. And one of the interesting things, yeah, I also saw what Yuri referred to, but the other interesting thing they pointed out is, at least for the task of Cora question pairs, I think what they said is, somewhere in the paper they mentioned that the org, NLP org or whatever, actually leads to worse scores using SBERT than not augmenting, which I thought was interesting. So they had apparently done with and without NLP org, and they said replacing words with synonyms, and what NLP org does seems, for the Cora question pair task, to give worse results than not using it, which I thought was interesting, because at least I would have thought that it would help narrow the gap between the validation and the training loss, because that's augmenting is one of the ways you do that. But it kind of seems to also align with what Steve tried and didn't get too much benefit from, which is, using the extending the data set by flipping the questions, because that also didn't give him any significant benefit, maybe incremental, but after the second decimal point. So that's all. Yes.
Curious at a high level, what is different when you swap the questions around in terms of what your model is doing? I'm just kind of, I currently have, I think, Gautam's model in my head where you're passing in those Q1 and Q2 through the two Lstms and then kind of comparing them. So I'm just wondering, how is it different if you swap or not swap the questions out? Does my question make sense?
Oh yeah. I can take a crack, and I'd love to hear others' thoughts on it too. Is for example, in the simple thing that I was doing using USC or SBERT, right? For example, so the sentence and I'm concatenating the two anyway, right? So at least for my model, for example, if I were to reverse it, then my the encodings would swap, right?
Right.
So
sorry, you mean the embeddings would swap to start with, right?
Yes. About when I concatenate, then the first so let's say Q1 and Q2 are my first. I pass Q1 and Q2, then I get an embedding for Q1 and an embedding for Q2, and then they are concatenated, right?
Okay.
And
so we have E1, E2 right now concatenated.
Correct. Correct. And then when the questions are swapped, the concatenation will be E2, E1.
Correct. Okay.
Right. And then I take the absolute difference of that and the element by product, and then I take it through the network, right?
Okay. So other than the E2, E1 getting swapped, the rest of the things are going to remain the same.
Yes, the rest will be the same.
Okay.
But so in BERT also, Steve, you would have the same, it would be the same thing, right? Because, well, in BERT, he would actually have even more of because I'm getting one embedding and I'm swapping. In Steve's case with BERT, every word of the question is getting an embedding, right? So when he swaps it, then every word is different when he swaps Q2 and Q1 than when he does Q1 and Q2, right?
Okay, so in essence, basically what is changing is just the positional embedding then, right?
Yes.
Okay.
That's correct.
Okay.
I think
any other thoughts? Sorry, go ahead, Gautam.
I was saying the only place where it theoretically won't help is in a Siamese network, because the LSTMs are the same since the weights are tight. You're using the same LSTM for question 1 and question 2. So even if you swap, nothing is going to change. So it should actually help everywhere else, but yeah, apparently not.
That's right.
Any other comments, Steve or Yuri or anyone else?
I'm on the phone now, and I'm not sure what the quality is, but I can't look it up myself. But I have a question with STS. So that's when STS is computed, does that give you the distance between questions, as opposed to when it's for like same or wrong, not the same question, it's only binary output, right?
Yeah, even in this case, when I do it for the question pair, it's still binary. The question that I don't know the answer to and I look into it is whether during training of the STS models, when they do semantic textual similarity, what losses and what actual training is done to get the model built, that I haven't looked into.
Because I think I finally kind of understood between, like, so what the difference is between those tasks, right? So in general, there's a task when you need to determine if two questions are the same, or you need to, you have like a giant array of sentences, and you want to find like more similar.
Yes.
There, like, I think one difference is, just time, because it takes a lot longer when you need to actually calculated the distance. But I think also maybe the optimal networks are not the same. So that's what but yeah, I don't know how well they translate into each other, but that's what I was looking at recently.
Yeah, yeah, that's why I wanted to try, because it's a related task while it's not an exactly the same task. As you point out, it's just trying, the semantic textual similarity just tries to find similar questions, whereas the Quora question pairs is more like, is it an exact, well, exact is not the proper word, but is it a duplicate?
Yeah.
Yeah. Sorry, Steve, any other thoughts on this flipping questions?
Well, I just assumed that, yeah, by flipping the questions, like the network would be learning sort of 2 questions in one position as opposed to learning 1. Yeah, like if you only have like 2 questions to start with, and you just put them in as like Q1 and Q2, then it learns like the positions, doesn't it, and the relevant words, and it's like attention or whatever in each question. And so by flipping them, you'd have thought you would have sort of doubled your training set effectively. Yeah. So like in Gautam's case with his current network where he has 2 separate LSTMs, in that case there, you would have thought, yeah, like each LSTM would be learning its own, it would be learning 2 questions and double the training set. Like obviously, as he said, yeah, if you share the weights, then there's no benefit from it.
No, actually, I think I was wrong. Even in that case, it shouldn't help, because like we discussed earlier, the first LSTM, if it gives E1 and second LSTM gives E2, then we are just making it E2 E1. That thing would still happen, right? Even if the weights are shared. I was wrong there. I think, yeah, it should help in all cases.
Yeah.
So did
Yeah,
it
like as I
actually
said,
drop your loss when you swapped it?
I think it like sort of fractionally helped. It sort of gave me like a slight benefit. But
Okay.
I didn't look into it fully. I just like sort of stuck it in, hoping that it was going to give me a big improvement, and then I didn't really see that. But it could be down to just how long I was training for and things. I haven't had a chance to sort of fully sort of compare how it would compare against not doing it.
Maybe Bert was just too smart. It did all that.
Maybe, yeah. Did you actually get a score, Gautam, with your
Yeah,
your
it's
model?
just 0.5, not much.
Right.
But I was able to get the gap between train and validation lower. So now I can just try bigger models and stuff. So I
Or
should
longer
get,
too, right? Because I thought you stopped quite soon.
yeah, exactly, yeah. And some of the kernels I saw in the competition, they have a list of replacements, like contracted words have been replaced by their expansions and stuff, like ain't becomes I won't, something like that. Yeah, just can't
A lot
becomes
of
can. Yeah.
pre-processing of
Yes.
text,
So
right?
that should help LSTMs, especially because I'm using glove embeddings. But yeah, probably not required for BERT and stuff, I think. But it should help for in my case.
Okay, I'll stop sharing. Anybody else want to share what they have done or submitted or tried? Okay, the one other, and let me again go back to sharing the
one other kind of quick, I haven't looked into it much, but among the other ideas that I saw is the thing that Gautam already alluded to, but it's also dealt with in this thing, is to try Siamese network for the classification. And apparently the nice thing is he refers, I haven't looked at it, but he refers to a master's thesis discussion of Siamese network. So if you're into Siamese network, that might prove to be a good resource to look into and to learn about it, but learn more about Siamese network and the application of that. And this blog post, and I think Yuri pointed out, this guy is actually the founder of Spacey and stuff. But there's a whole post, sorry about the scrolling, but it talks about using Siamese network. Similarly, this is the other paper that is referred to either by the Spacey post or by one of the references in one of the blog posts in the Kaggle competition itself. And this is again, if I'm not mistaken, is Siamese model is my recollection, but I could be wrong. But this is another paper that it seems implementation of this paper is something that's used to get fairly good scores on this task. So that's something else to look into, of how to, or what is implemented by this paper for implementation, or as a potential solution for this task. And Raquel is always interested in autoencoders, and apparently there's a way by which, and I haven't looked at the details, but again, if people are interested in trying new ideas, there's apparently autoencoders for paraphrase detection, and this methodology or this paper has also been implemented to try and address the duplicate question identification as well. So that's another potential direction to try. So, besides the LSTM route and besides the usage of USE or SBERT, which are sentence-based encoding methods, and then trying to augment them, because obviously we have seen that just using them doesn't get us even in the top 1,000. And then, of course, Steve demonstrated BERT does get you in the top 1,000, but just barely, I think. So.
Oh no, I haven't made it yet. I'm still slightly outside.
Yeah, I was pushing you up there, Steve.
Thanks very much, but no, I haven't crossed the line yet.
But by far, you're still better than any other score. So at least closest to 1,000. And here are a couple more ideas, of things to try. The Siamese network is one, and then this autoencoding route is another. So let's kind of keep pushing and trying different methods to see which gets us higher, and at least into the 1,000, hopefully much closer to the top. And by the way, I think there are a couple more ideas in what Gautam was implementing as well, because I'll stop sharing, but Gautam, if you have the reference handy of the Quora guys' ideas, I think they're two other ideas or variation of, one of them is a variation of what you're doing, and then there is a second one which isn't. So if you can just share those pictures, those are a couple of other, I'll stop sharing. Yeah, that was one. Then this is the other one, right? Yeah, what are they doing there? Just taking the difference and the dot product. So that's it.
Difference dot product, and then I guess they are concatenating and dense layers on top of that.
Okay, so it's just basically what I said of absolute difference and element wise multiplication and then taking it through the network. In fact, that's what I was suggesting
Yeah,
for
it's the
you too,
same.
right?
Yeah.
Basically.
Yes.
Yeah. Once you have the hidden layer, you can do this part very simply.
Yes.
They had one more idea, I thought, right?
Attention, I think.
Yeah, attention. Okay, that would be interesting what they did with that. Decomposable attention. That's the paper that I think is, there's a paper reference that they give on that decomposable attention. I think it's right below where you are right now, just a little bit further down.
Okay, this one.
Yeah.
Okay.
And that would be another idea to try.
And they got accuracy of 88 on the test
Oh,
set.
that's yet another paper, by the way, those guys. That's a different paper than the decomposable one. Yeah, that's a different paper. That's an interesting one too, because it's a variation yet again.
And all of these are like 3 years ago, more than 3 years
Yeah,
ago.
yeah, exactly. So the only thing which has gotten even in the range of 1,000 is the Steve's Burt, which, I'm kind of impressed that 3 years back, all these other techniques which are more traditional still got people such high scores on this task.
So are all the top kernels like feature engineering ones? Like, did they make their own features? And
Yep, a lot of it is like that. And then, in fact, I just duplicated a XGBoost one that I ran. And what's kind of somewhat embarrassing is that gave like, if I recall correctly, 0.16. And we have, with all this stuff that I've submitted, I'm still at 0.33 best case.
I think I can just take my hidden state of the LSTM and I'll just combine those features to my LSTM output,
And try.
yeah, that should
Yeah.
theoretically be better than what they got.
Yeah, because this XGBoost thing, I just wanted, that was my first submission to check whether the submissions work. And then I just duplicated somebody's work. I mean, I didn't care about what he was doing. And then the score is 0.16. And these things are still at 0.31. So there's quite a ways to go.
Yeah,
But
I'll definitely try this one out. Yeah.
yeah, that's a slight variation for you. So it ought to improve your score, I think, because at least I saw quite a bit of a jump when I did the USC and SBERT and I did the subtraction and element wise product. So, okay, so there are like several things to try, which is our goal. And before we dive into, what are the state of the art for this particular task, I just want us to get either happy by getting much better scores or get really frustrated saying, what are we running out of ideas to try? Or because that will give us a lot of motivation to really understand the state of the art techniques and what people are doing. Because nothing like productively failing and getting frustrated to really learn to do things better. So with that, anyone else wants to add anything to our discussion?
Just a small thing, like the advantage of LSTMs is that it's pretty fast compared to like what you guys have been saying for BERT and stuff. So for me, like 10 epochs takes probably half an hour or something. It's yeah, literally quite faster.
Oh yeah, definitely. Yep. No, actually, the my so the whole thing. How long does it take for you to run through both training and inference?
I have not timed it, but I'm sure it's
Roughly.
not more than 40 minutes or so, I think.
Oh, okay.
The whole
That's
thing,
pretty
yeah.
quick. Yeah. I think at least, until I did this Roberta large model, most of the rest of it with SBERT or with USE was probably in the order of an hour to an hour and 15 minutes max. It wasn't this 3 hour, 4 hour thing with the Roberta Lodge, because the issue with the Roberta Lodge that I saw is the training itself, as I said, took a long time. Training typically only took less than an hour, and this took almost uh, at least greater than 2, and then inference itself took 3 hours. So okay, anybody last call want to chime in with anything? Okay, let's see next week who can break the 1,000 barrier. Good luck. Thanks for joining, folks. See you all next week, and post any links or methods you think of.